So arcs and chords. This is not a really intense or difficult section. There's one major piece here I want us to get because of some application that we have to it and some other things that we're going to do. But we're talking about arcs and chords. We've already talked a little bit about arcs and chords, and we're just going to be looking at some of the relationships that we can have. Now here's another if and only if theorem. And this just says that in the same circle of congruent circles, if two minor arcs are congruent, oops, let me fix that. If two minor arcs are congruent, then the two chords that connect the endpoints of the arcs are also congruent. And that's an if and only if, which means it works both ways. The converse is true as well. So we can use those things to help us in a problem like this. They tell us that a circular piece of jade is hung from a chain by two wires around the stone. They tell us that the two segments are congruent. You can see those are marked easily. And they tell us that the measure of arc KL is 90. If that's 90, then guess what MJ is, or the measure of arc JM? It's also 90. And it's also 90. So those are congruent. We can see how those, so it's really easy stuff. It's just you gotta know it, but it's nothing, there's no real work here, or no difficult work here. So they tell us it's a circle W, center is W, and it has congruent chords, and they've marked those already. And they tell us that the measure of arc RS is 85. So you can see from here to here, the measure is 85. And remember, that's not arc length, that's arc measure. And they asked us to find this arc here. And since the two chords are congruent, the two arcs are congruent, so it is B85. So we're moving along here. Now instead of it all being one circle, it's two circles. But guess what the circles are? Congruent circles. So it might as well just be mapped onto that because they're congruent circles. They have the same center, they have the same amount, same radius. So they tell us, because that theorem told us that it would work this way, not just for the same circle, but for congruent circles, the if and only if. But they tell us then the two arcs are congruent. So guess what we know about the two chords that touch the endpoints of the arc? They're also congruent. In other words, we can say that 7x minus 2 is equal to 5x plus 6. So a little solving, you get the 2x equal 8, and so x is 4. Well, they asked us to find. Did they ask us to find x? No, they didn't. But I needed to find it so that I can now plug it in and find the length of this segment or this chord. So I put the 4 in here, that's 28, be 26. I'm going to do this one too, put the 4 in here, be 20, plus 6 is 26. Because I like to check to make sure that it worked, and it did work. The two chords are congruent because the two arcs are congruent, but the answer to the question is find the measure of WX. It's 26. Somewhere, there it is. So we carry on with this kind of stuff. There's just more of the same. It's more of the same kind of stuff. And let's look at this. So it says if a diameter or radius of a circle is perpendicular to a chord, then it bisects the chord. And this is a really big deal. This is a diameter, which also is part of it is the radius. That's why it says if a diameter or a radius. Because if it's a diameter, then it includes a radius. If it's perpendicular to a chord, then it bisects the chord. In other words, that piece is congruent to that piece. And that's a big deal. To be able to know that, to be able to be sure of that, it's pretty good stuff. And it helps us to do some problem solving. Now, the next theorem is so kin to this one, it looks like it ought to be another if and only if, but it's not, because it doesn't exactly fit that way. But it says the perpendicular bisector of a chord is a diameter. So the perpendicular bisector of a chord, if it's perpendicular and it bisects it, then it had to be a diameter, that has to be a radius. Okay, but those are nice connections to have, nice pieces of information to know. So they tell us that in a circle G, center is G, the measure of arc DEF is 150. So I'm just going to mark that 150. find the measure of arc DE. Since this radius is perpendicular to this chord, if that's 90, then that's 90. Does that make sense? So that is going to mean this. Let me get a different color here. That's going to mean this arc is congruent to this arc. If the whole thing is 150, then each piece is 75. 75. So we have another circle, we have another arc, WUX is 160, whole thing's 160. And they want to know this piece. This piece. What is it? If the whole thing's 160, then it is 80. You can use that in doing some problem solving. So I'm going to apply this information up here back to this problem. In the ceramic stepping stone below, diameter AB, which is this thing here, is 18 inches, which means from here to here is what? If the diameter is 18 inches, then that's 9 inches. Okay? Take note of that. And chord EF is 8 inches. Now EF, need to pull down just a little bit. EF is here. And that's 8 inches, which means this piece is what? 4 inches. Because remember, if the radius is perpendicular to a chord, it bisects the chord, so this would be 4 and this would be 4. Are you with me? And it says find CD. So they want to know this. I'm making that exaggerated so that we can see what we're looking for. Now the whole thing is 9. If we knew that piece, we could subtract and we know that piece, but we don't have that piece. And there's really no way for us to get that piece at this point. So this is that one thing that I said, the reason why I wanted to do this, because some of it's pretty easy, pretty obvious. This is the big piece. And not just is it the big piece for here and for now, but it's the big piece for some other things we're going to do. Because here you sit with this problem. We've applied all the information that we have as far as what they gave us. We've got it all labeled. And we're looking at it and we're thinking, I don't know. I don't know how to do that. I don't know how to find that piece of information. How would I know? How could I know? Well, there's a trick. And that's what happens to us as we explore mathematics. A lot of times there are tricks. And our experience helps us to experience those tricks. Our practice, our exposure in class, or in this case, this video, is going to help us to see. Nobody's telling us to do this. Nobody's told us to do this, but I'm telling you now, I'm going to draw a segment right here. That segment is a radius, therefore it is 9 inches. You do agree that's a radius, right? Went from the center to the circle. So it's 9 inches long. And what that does is that gives us a right triangle. A right triangle where we know hypotenuse is 9, one leg is 4, and the other leg is that green thing I'm trying to find, which is the length of CD. So I'm going to use my old friend, the Pythagorean theorem, where the C, the hypotenuse, is 9. One leg I don't know, so I'm just going to leave it as a squared. And the other leg is 4, so 4 squared is 16. So a squared is going to be equal to 65, I believe. So a is going to be equal to the square root of 65, which is like 8.1 or something like that. Let's see what they say here. So see they say draw radius? Now, nobody told us to do that, like there's nothing in that problem that says do that. So you kinda you gotta learn to be suspicious of the possibilities. And I guess that's the point I wanted to make with this particular problem. Be suspicious of the possibilities, because something like that could happen. There's nobody that says we can't do it, we just may not have thought that we needed to do it. May not have had that occur to us in a whole week of staring at that problem. So you can see the square root of 65 is that measure. If you get it, it's about 8.06, which would round to 8.1, but that's probably a better rounding to the nearest hundredth. But anyway, you can see how that works, use Pythagorean theorem. Don't ever write it this way with, always put the c squared equal a squared like we do in class. And so in doing more of these problems, it's the same stuff. I mean, you're gonna need to do something very similar to what we did in the last problem, and probably draw in this radius and use the information here. I will say that since the diameter is 14, the radius is 7. So if you're gonna do that, you need 7. You need to make sure you labeled it correctly. And this would be 5, and this would be the thing we don't know to get from here to here. Because that's what they're asking us for, right, is VU. So you can see your right triangle, Pythagorean theorem, and so on. All right, last part. In theorem 10.5, it says, in the same circle or in concentric circles, two chords are congruent if and only if they are equidistant from the center. Equidistant from the center. So we've got this circle, we've got these two chords, and they tell us the two chords are congruent if they're equidistant from the center. Now remember, distance. I could draw all kinds of chords in here, or segments rather, from the chord to the diameter, or the chord to the center. Okay, I could draw all kinds of them, but only one of them is going to be perpendicular. And remember, distance is going to be perpendicular. We talked about it in our classroom, we talked about it, we did triangles, and so that's why we know that has to be a 90-degree angle or a right angle, because that's what distance or height or altitude does. So that's that piece. So we have two chords that are congruent if these two things are congruent, or vice versa, because we have if and only if. So just a quick application of a couple problems here to help us to see this. It says we got circle P. It tells us that EF is 24, that GH is 24, and it says find PQ. In other words, if this is congruent to this, because that's all the 24 is good for, is to tell us that that's what that is, then this is congruent to this. Since we have two algebraic measures, those two things have to be equal. A little solving, you get 2x equals 6, and x is 3. Did they ask us to find the x? No, they asked us to find PQ. So we take the 3, plug it back in here to find the length of PQ. That'd be 12 minus 3 is 9. Just for checking, you put the 3 in there, it'd be 6 plus 3 is also 9. That works beautifully. Answer is 9. And again, more problems, more practice, same stuff.